So here we have a function f of two variable x and y. It's given by xy cubed plus x squared y squared. Then we need to find out the second partial derivative of f with respect to x and y. Okay, we'll try to understand it step by step. First, let us begin by computing the first partial derivative. So we start with our given function. So here we are given f of x comma y. So it's a function of two variable x and y. That's x times y cubed plus x squared y squared. Right. Now what we'll do, we'll take the partial derivative on both sides with respect to x. We have partial with respect to x of the function x y cubed plus x squared y squared. Now using the laws of derivatives, what we can do, we can break it down into two partial derivatives. So we have partial with respect to x of x y cubed plus partial with respect to x of x squared y squared. Okay, now whenever we're taking the partial derivative with respect to x, that means only x is the variable here. Everything else will be treated as a constant. So we have another variable y. So y will be treated as a constant. Since y is a constant, y cube will be also a constant. And for the second term, y squared is also going to be a constant. So what we can do, we can pull it out of the derivative. So we have y cube times partial with respect to x of x plus y squared times partial with respect to x of x squared. Now what we can do, we can use the rules for ordinary derivative. So we can take simply y cubed times the derivative of x with respect to x. So that's going to be 1. This will be added to y squared times derivative of x squared with respect to x. All we have to do is use the power rule to get 2x. So finally we have y cubed plus 2xy squared. So this is going to be the partial derivative of our function f with respect to x. Okay, we're going to label this as number 1. Now what we'll do, we'll compute the partial derivative of our function f with respect to y. So this will be equals to partial with respect to y of our function, which is given by xy cubed plus x squared y squared. So this will be equals to, we have partial with respect to y of xy cubed added to partial with respect to y of x squared y squared. Now for the first term, since we are taking the partial derivative with respect to y, so only y will be the variable, everything else will be a constant. So in our case, x is going to be treated as a constant. And for the second term, x squared will become the constant. So we can pull out the constant. Your x will be multiplied to partial with respect to y of y cubed added to x squared times partial with respect to y of y squared. So this will be equals to x times the derivative of y cubed. So using the power rule, we get 3y squared added to x squared times derivative of y squared with respect to y. So that's simply 2y. Fine. So we have 3xy squared plus 2x squared y. And this is going to be partial derivative of our function f with respect to y. We're going to label this as number 2. So our goal is to obtain the second partial derivative of f with respect to x and y. What does it mean? So let's try to understand it. So our goal will be to find out the value of second partial derivative of the function f with respect to x followed by y. So always we have to read from left hand side to the right hand side. So this can be actually broken down as, we'll first have to take the partial derivative of function f with respect to x. And then once we get that value, we'll have to take the second partial derivative with respect to y. So this is how we can read a second order partial derivative. Fine. Now we have already obtained the value of partial of f with respect to x. So that's given in equation number 1. So let's substitute it here. Now we have partial with respect to y of, so in place of partial of f with respect to x, we're going to replace it with y cubed plus 2xy squared. Now the rules are going to remain the same. So we have partial with respect to y of y cubed plus partial with respect to y of 2xy squared. Since we're taking the partial derivative with respect to y, only thing we have to do is treat y as the variable. Everything else will be a constant. So partial of y cubed with respect to y, that's simply 3y squared using the power rule. And here we have 2x, that is the constant. And we will be left with partial of y squared with respect to y. So that's going to be 2y. That means our final result will be 3y squared plus 2 times 2, that's 4. So we have 4 times xy. So this is going to be the value of the second partial derivative of f with respect to x, then y. Okay, our next task will be to obtain the second partial derivative of our function f with respect to y first, followed by x. That means we'll first have to compute the partial of f with respect to y, and then whatever result we obtain, we'll again have to take its partial with respect to x. Okay, we have already obtained the partial derivative of f with respect to 1, so we're going to use equation number 2, and that's going to be simply 3xy squared plus 2x squared y. We will get the partial with respect to x of 3xy squared added to partial with respect to x of 2x squared y. So this will be equals to, so we have 3y squared multiplied to partial with respect to x of x. So we have treated 3y squared as a constant, so we have pulled it out since we are taking the partial with respect to x. So x is the variable here. And then for the second term, we pull out 2y and multiply it to partial with respect to x of x squared. So we get 3y squared times the partial of x with respect to x, that's going to be simply 1. This will be added to 2y times partial of x squared with respect to x, so that's equals to 2x. So we get the result 3y squared plus 4 times xy. So this is going to be the value of second partial derivative of our function f with respect to y first, followed by x. Now clearly we can observe here our actually problem is solved. We were asked to obtain the value of these two partial derivatives. Now here we can see that the second partial derivative of f with respect to x followed by y, this value is exactly equals to second partial derivative of f with respect to y, then x. So whenever this criterion is followed, whatever to get is a theorem known as the, or what we get is an equation known as the Clairaut's equation. So this is just an added information I have included here. We'll be using this later on. So we have successfully obtained the value of the second partial derivative of a given function.